Okay, thank you. I hope you guys enjoy the puzzles. The puzzle is by TED. You think, why do I want to watch it? First of all, it's related to our today's problem about like the 2D grid or an array. Second of all, it has a lot of computer science jargons problem in our paradigm in that. I will explain it later. Third, I think that's quite important. When you got a problem or assignment in our course or your discipline, usually how do you feel? There are some people will think that, oh, I just finished it, submit it, I'm okay. I'm cruel to say that these people will at most get a B. Okay? I'm not trying to scold you, whatever, okay? I'm trying to tell you what is happening in university. University, originally, the form is to bring out you, the word university or education. That means you need to have an interest, investigate, or find out more other than the requirements. If you have that issue, you think, oh, this problem is interesting. Let me see more. For example, if I introduce TED, this is TED, they have a lot of puzzles like that in different way of logic, programming, math, or humanity. Oh, let's go and watch it. If you have that kind of curiosity heart, you really will excel in your career and life. I think one of the downside of our Asian culture education is you need to fulfill what your teacher said, not in university anymore, and especially not in your career anymore. It's okay? And most importantly, not in your dating anymore. You don't try to satisfy the other part. You think what you want to do, okay? About the second part, this is a problem about Hamiltonian cycle. There's a lot of jargon here. First of all, Hamiltonian cycle is if you have a graph,
exactly once.
and you find a path that you only visit the site once, okay? It is convenient for shopping. If let's say you go to a big mall, a huge mall, you want to go for every shop exactly once to save your time. Then you find a path, okay? There's a Hamiltonian path. That's the path, but the important point is you must go for every shop or every point. You must travel once, and you can only travel once. There's a hard part, okay? So think about that. There's a path. Second jargon is to find such a path in a graph, you can verify, but you cannot find the answer. Does it make sense? You can verify if the answer is correct, but you don't know how to find the answer. That's what math do usually. And also, this is the key point here. Okay, I don't have the slide. Yeah, this one.
Is the policy difficult, please? Is the
NP complete. NP complete is a computer science term because let's don't talk about AI, okay? We are not talking about AI. This is something AI cannot solve. This is called algorithms. Like just a very brief explanation, what is the difference between AI and algorithms? How AI learns? AI go to the web and see, to crawl your data. Oh, 21 plus 21 equals 42. 21 plus 21 equals 42. They see 11 people talk about that. AI learned, oh, 21 plus 21 equal to 42. That's how AI learned. How algorithm do it is 21 is like your math lah. 21, 1 plus 1 is 2, 2 plus 2 is 4. That's what algorithms. A lot of time, algorithms can do a more precise, faster way to solve problem, especially computational problem. However, we also know algorithm has a limit. Your computer have a limit. How do we tell? If you cannot do it, doesn't mean it's hard. Is your computer cannot solve it? Computer scientists study this problem. Like, is it our human race dumb, so dumb that we don't know that can be solved? Or is it because it really cannot be solved? Do you understand what I mean? For example, in the past, people think our smallest particle is atom. That was how many years ago? And there was some time before thought the Newtonian mechanics is the ultimate law of universe. And then become Einstein, become the string theory, right? So there was one in our human race or human era, we thought something is the limit. We always break them. So one of the things we need to think in computer science is, are we dumb enough? Are we so dumb that we cannot solve the problem? Or is it really notoriously hard? So computer science has one way to think that. They find some problem called NP-complete. That means there's a group of problems you can mathematically prove that it's hard. Okay? And how they prove it is a bit unfair. They make one problem is very, very hard. Everybody thinks it's very hard. And they think, oh, if other problem can translate solving that problem, it's also hard. That means if that very hard problem cannot be solved by all those great people in the past, this problem also cannot be solved because so many people cannot solve. That's how computer scientists do, but they need a proof, okay? That's called NP-completeness. And also, there was small jokes later. Actually, this problem, other than the mathematical term called Hamiltonian path, in usually computer science, we call it the traveling salesman problem. That means there's a traveling salesman want to visit all the homes in the town, but visit only once. That's also the same. And interestingly, this kind of problem can be translated to other problems. For example, there's one problem you never thought of is related. One problem called logic satisfying problem. I give you a logical clause, X and A, or not A and Y, whatever. You have a lot of variables. Can you find an X, Y, A, B, C such as satisfying this logical equation to be true? That problem is equivalent to this. That means if you can solve this, you can solve that. So they have a way to translate. But anyway, I think I have enough. So let's start. We'll talk about this. And it's highly related because we do 2 grades today, okay? But before that, how's your midterm? I saw a lot of smiling. That means it's good. No, not even good. It's very, very good. Okay. But I walked around, I saw quite good. Like the first half hour, I see a lot of people already reaching question 20 something. I don't know, I walk around and see that, okay? It's just visually checking. Yeah. But at least when I walk around on the first hour, I mean at the 30 minutes time, I saw people are already reaching question 17 or 18. That was like the smallest. It's only a few people until 10 or something, okay? So I thought the MCQ is good, but the last part is supposed to be hard, okay? The fill in the blanks, okay? So the last fill in the blanks is supposed to differentiate those B and A students, okay? We'll talk about the midterm answer later, okay? So don't worry about it. But at this point, please rest. I think you done good enough. And lastly, I think Henry brought in some leftover. Anyone leave your stuff? There was just one guy coming saying leaving his charger, whatever. Yeah. So you can come out and maybe Prof. Henry can help me to please handle this. Yeah. Later you can come and get it. Okay. Thank you. Okay, let's start our lesson. Yeah. Don't worry, this graph is last year. I didn't compute the graph yet. We didn't mark it yet. Okay. Just want you to know that this year, this is the last year, the PE mark, okay? The PE1, we don't have PE1 at the first beginning. Okay, multi-dimensional array. Wow, does it name sounds very cheap, very profound? Yeah. How many dimensions are we living in now? 5? 4? How many? 4? 4 means X, Y, Z, and time. That's the usual things. Okay. So that is the question. If you talk about dimension in geometry, 1 dimension means you only have a line. Basically, if you use math, it's only one value. Your number is equal to X. X equal to 1, 2, 3, 4, 5 in continuous number. This number line is called 1 dimension. And you know what is 2-dimensional geometry? You have X, Y. Okay, then you can move up to 3 dimension, which is what we are at. I can punch you here, I can punch you here, I can punch you here, okay? So that's 3 dimension. But of course, we assume we are moving in time. Some scientists believe time is an illusion. Some scientists believe there's no such thing as time. Okay, time is just something like space, whatever. Some scientists believe in that. And some scientists, of course, believe it's a parallel universe and so on, okay? But let's see how many dimensions are in time later. So we have been doing something one-dimensional. If you store things in a list, it's called a one-dimensional list because you can only go back and forth in the index 0, 1, 2, 3, 4. But it's like our hall here is not one-dimensional. It's 2-dimensional. You can store it in a table. So it's like, I think you guys is in the engineering, you know what is a matrix. Anyone don't know what is a matrix? Don't be shy. Oh, really? You don't know what is a matrix? Okay. I thought you guys saw them. Matrix is a 2-dimensional math grid. And one-dimensional, you only need to go for 1 index. But 2-dimension, you want to have 2 index. Okay. And you can even have 3-dimensional grid. And what is the use of that? You in something called what? Some BA course. I mean or humanity course. They call this multi-dimensional data model or analysis. But actually, it's just multi-dimensional array. What it does is you just put the number in an array like that. For example, this is a complicated example. This is a simple example. This is a sales number. So I put the sales number in each of this square, each of this cube. One way. So the red arrows is to move around different items in your company selling. You have clothes, you have bikes, you have books. The other one is which country you are selling to and which year. So this is, you can see it's a 3 by 3 by 3 grid. Of course, the number of cube by each line can be larger. It can be 4 by 5 by 6. But if you have that, it's a 3-dimensional grid. You can duplicate this cube into one is your budget or your prediction or projection. One is the actual sale. Then become a 4-dimensional grid. That's how salespeople predict this kind of thing, okay? And that's called it multi-dimensional whatever, but it's actually just arrays. And you have been doing it in your Excel. Your Excel is naturally a 2-dimensional table. But your Excel table is actually, I hope you know how to do Excel, okay? You can write some formula to refer to some of the cells, right? And you locate the cells by the column alphabet and the row number. For example, the number B1 or this one is I9 is supposed to reference to that. And of course, anyone play Minecraft or those kind of thing? I don't know if we can it's 3-dimensional because is you can rotate and so on. Some people actually make very impressive. I think I remember some people make the whole library into the Minecraft or duplicate some city in the Minecraft, okay? But there's all 3-dimension. Well, these are entertainment. You guys are still young, but there will one day you may go to do CT scan or ultrasound. Those are 3-dimensional grid. That means this scan is actually scanning the, you guys are engineering students, I talk in technical term. They actually have different space in your body, they scan the density. And if you extract a certain density, for example, I want density less than something, then you come up with your brain now. Of course, provided that your brain has some densities, okay? Different from water, okay? And you know your brain density is different from the fluid density around it. So if you just extract the brain density CT scan, then you have your brain, okay? And so on. But of course, the real CT scan will have a lot more smaller cubes, okay? But this is just visualizing the cubes like that. And of course, if you guys one day you have babies, you have that. Okay, so let's don't talk about two high array first, two high dimension first. Let's talk about two dimension first. Ritual times. When I was young in US studying, one thing we would like to do in holidays is to travel. For example, there was one time we go to the US Universal Studio and Disneyland in Florida. However, we have no money. How? We cannot afford the air ticket. But one thing good in US is you can rent a car. Renting car is very cheap. It's about, I would say at that time, it's about $40 Singapore dollar for one day. Yeah, but if you rent a car, that means you can share by many people. There was one real incident, we rent a van and share by 6 people for 2 weeks. So you can calculate $30 per day, 7 people, everybody is $60. You can have a 2 weeks trip for traveling, okay? But of course, the problem if you drive is very long. My longest drive in a row is 17 hours. But also a lot of time we drove more than that. So in the middle of it, in US, we have a lot of this thing called motel. What is a motel? Motel is something like a hotel, but it's mobile for cars. What is the difference? The motel usually is very simple. You can go in and then the keeper will just tell you, oh, which is the room you are in. Okay, usually 99% of the motel is one level. Only one level. So you can only access by the room by 0, 1, 2, 3, 4. This is called a one-dimensional hotel. Okay, you only have one dimension. You cannot choose, can I stay in the second floor? You cannot. Okay, and also all usually, actually not 90%. All of this motel has no facility like the hotel. Why? You know, the real hotel is like that. Anyone went there before? The Legoland. Okay. Hotel does not only have rooms. A lot of hotel has what? Massage lah. Some hotel even have barbers for cutting hair. They have swimming pool. Some hotel even have shopping mall, or even usually in our old days, hotels is a desk when they have some tailor. They even can make a suit inside the hotel whatsoever, okay? So anyway, but if you go to hotel, of course, the first thing is the rooms will not be one dimension. You will be one floor, you have many rooms, and then you go up the floor, right? So if, let's say you go to a hotel, you have to tell people, for example, I go to the hotel, I got a room, I need to tell people maybe my room is in 2nd floor, 5th room. So usually it's like that, right? And also, anyone play chess here? Yeah, you know the chess. Are you a good player, expert player? But you know, usually people play chess, they don't have the graphical board. They record the position, right? For example, this one is, this queen is at the position, row 8 and column D. So you actually have a record for column D and position row 1 in or row 8 in to specify the position. Some people can play chess blindfolded. You tell them which from C8 move to C4, whatever. They can memorize the chessboard just by hearing and tell you, okay, I want to move my whatever if I'm right, whatever. People can do that. Those very good players, okay? Yeah, there was one Hong Kong movie about that. There was this guy blindfold and do chess, okay? But anyway, that means you can translate this into positions. Yeah. And of course, we do Excel. We just talk about, so one thing so far you actually recognize, if you want to do this 2D tabling, you need an address for the cell. Usually it's by the column label and the row label. Okay, but luckily for most of this application like chess or Excel, the column is an alphabet. The row is a number, but too bad, in Python it's not, okay? Sorry about that. Okay, so in our Python Actually, in most of our so-called implementation for most of computer languages, anything like C++, Java, we use numbers. In one-dimensional array, you just need one number because you just need to indicate one dimension position. But in a two-dimensional array, you need two numbers. Okay? But one thing, philosophically, if is 4 the row or 1 the row? Actually, there's no definition because in most of the matrix, whatever, they doesn't matter how you draw it. But the convention is usually the first index is the row. The second index is the column. Okay. So this is what you're very familiar with, one-dimensional array. This 1, 2, 3, 4. And the index 3 is 4. What is a two-dimensional array? It just, you knew it actually. It's just list of lists. So think of this, a two-dimensional array is just a list of rows. This is important, okay? A two-dimensional array is just a list of rows. And each row is a row. Okay? So for example, what is this? You can see this one have 2 rows and 2 columns. And you can access each of the array entry with 2 indexes, like that. So it's the row number, this is the column index. And if you want to visualize it, this matrix is equivalent to a matrix like that. But interestingly, the row is counting from the top. I know that there's some mathematical definition, the row is counting from the bottom, whatever, but usually, as programmer did, row is counting from the top. The top row is 0, the second row is 1, the third row, and all the way to the last one. And column is counting from left to right. That is natural, okay? So this is how we define a 2x2 array. What is the difference between a list of lists and two-dimensional array? More specifically, a list of lists is, you have a list of lists, and any of the lists inside can have a different length. Okay, this is called a list of lists. And this is total length 3 because there's 3 lists, but each of the lists inside can have a different length. So we don't call this a 2D array. A 2D array is actually, you can think of, is a subset, or we call it a special instance of the list of lists. That is actually one small constraint is like this. Each of the lists inside the array can be of any length, but they have to be the same. For example, this is length 2. This has to be length 2 and length 2, right? Because each of them is a row. Every row, they should have the same number of columns. They cannot, let's say, if you have 2 table, one suddenly come out with more more columns or less column. That doesn't make up a 2D tables. So they have, but the number of columns, the number of rows can be different. So this one is 3 rows and 2 columns. Okay. And the visualize the array should be something like that. Not array, the matrix. So I can create a large matrix. This is a 4 times 10 matrix. 4 rows times 10 column. Usually is A times B means A rows and B columns. So RC, okay? Remember the order is remote control. Remote control, okay? Remote control, row and column. The first one is the row number, and the second one is the column number. One thing about raw Python is, if you see the list like that, it's very messy. Usually, sorry, I'm from the graphic side. I need things to be pleasant to my eyes. I don't like ugly. So let me introduce one package called pprint. You can import a package called pprint So what I usually do is from pprint import star. Then you have a function called pprint. Pprint stands for pretty print. It does not do anything for you. But if you want to print things, it will print nicer for you to see. Okay, it will format and some automatic thing to make it. For example, this 2D array, if you're using a pprint, you will make it like this one a lot easier, right? A lot prettier to see. So the pprint is a package, have no use, but only make it easier for you to see. And here, how do you know in a given 2D array how many rows are there? Very simple. The list is containing all the rows. You just have to ask what is the length of that list overall. There's a number of rows. And how do you know how many number of columns? You ask the first row. You see what is the length of the first row, or of course, theoretically, you can ask any row if they're the same, okay? So you can use any rows, then you return the number of rows and columns. Let's try to write function to do some application. For example, how do I create an n by n identical matrix? I hope you guys know what's identical matrix. You guys been to your A level, right? How many was not from A level or didn't know what is identical matrix? But do you know identical matrix? Or you don't know what is identical matrix? Okay. Identical matrix, usually matrix is a 2D grid of numbers. And identical matrix is a square numbers. That means square means the number of rows and the number of columns has to be the same. All the entries are zeros except the diagonal. This is called identical matrix, okay? So for identical matrix, how do I so-called create it? I can create an output, and each time here, I append a row. Okay? I will, for I in J, I append a row n times, but I do this. The J is appending each rows one by one here. Okay? What is that things? You say, hey, I never see it before. Can I do if like that? Usually you do an if then else statement, right? But if you want to be lazy, you can do this. What does this do? Read it with me. 1 if I equal J else 0. Does that make sense already? That means you will compare I is equal to J. If I equal to J, we return 1. Otherwise, else 0. That is how it does. Okay? So you want some Python. So you can see here is my salary is equal to 1,000. So reach print reach if salary larger than 10,000, else poor. Okay, so poor. It's okay. So if I increase my salary to what 100,000, then I print again, become rich. Okay, so you compare the central part. If it's true, I return this, and otherwise I return this. This convention is actually from C. C have this question mark colon thing. So C have this, we call it a ternary operator. C plus ternary operators. We have this shorthand of if then else, which is inherited from C. So it's but C is different. C is the condition first, then expression true or false, which is a bit hard. If in Python, it's very intuitive because when you read it, it's what it is. What does it print? It print rich if salary larger than 10,000, else poor. You can almost know it from reading, okay? So that's why Python is good. So here, it will be 1 if I equal to J. What is IJJ? IJ is the column number and the row number. So for the diagonal, all the column number and the row number are equals. So this one is having the index 00, index 11, index 22, index 33, and so on. So if the index are the same, it's the diagonal. We put a 1. Otherwise, we put 0. Okay. But what I want to say is the following slide is only for my course. Why? Because I still find this a bit hard to how to look at. So I create one function called this. Instead of printing a matrix like that, I want to print it like this. How? I use something called M-type print. Don't question my name. I'll anyhow do it 10 years ago. Okay. So what I did is I look through all the I and J, and for each of them, I will make a string and print it. Okay, it's just printing that without all those comma, space, and all this square blanket. I just extract the number. And also this is only useful if each of the entry after it's converted to string is a single character. Okay, so it's just for convenience. It's not teaching you something good about Python, but it's just for our CS1010E course, we do that. Okay, another one is not every time you need an identical matrix. Sometimes you need any matrix with all 0, and you also may not only need a matrix with square. You can have any rows and any column that the number of rows may not equal the number of columns. So I do this. This is called create 0 matrix. And I do an output, and I slowly append a 0 to each row, and then I put it in the output. But you say, why is it so dumb? Why don't I do this? Yeah. Text. Okay. Whatever it is. Why don't I do this? Create matrix, okay? I'll see. Why don't I make a row? A row is equal to times C. Okay? This is one row. How many 0 are there? C, right? And then column, and then output row times out. That should work. Why don't I do this? Let's try from pprint import start. For example, let's say I pprint create matrix. How many rows? Maybe 7 rows and 20 columns. Sorry, not output. Return, sorry. Hey, I thought it works or not. Is it working? Let's try again. I think I said M is equal to this one. Pretty print M, right? Okay. I want to change the first entry to 9. What happened now? Whoa. What happened? What is the problem? If you went to the tutorial, we explained it. Because it's called the aliasing problem. Every row is the same row. They point to the same thing, okay? So you cannot create a matrix like that because then every row is the same. One way you can do it is, I think you can do list comprehension. Let's try this. Okay. And then let's try it again. I modify this one, and now I print. Aha, it works. Because I use the copy. Every row is a new duplication or clone of the row. So be careful of when you're creating any of the row, they have to be independent. Of course, I can shorten this like this. I can do, anyway, you play around, okay? So it's a one-line grading matrix, okay? Yeah, so if I do this again, I change the first 1 to 9, I print again, yeah. It works, okay? So this is just a show off, okay? So a lot of time you can change a lot of things in Python into one line. But of course, this one is for easier understanding. That's why I put it in the first place, okay? Okay. Remember that usually when you talk about the index here, the first one is the row and the second is the index. This slide is just to emphasize once more. For example, index 1, row 1, column 3. Row 1 is actually, this one is row 0. This one is row 1. We count from the top. And column is 0, 1, 2, 3, count from the left. Okay, enough Python. Let's talk about how do we use it. That is more interesting, okay? For example, of course, the usual thing you can do is do it for your matrix lah. But it's boring. I just talk about it one minute, okay? You guys do it yourself when you do your engineering homework. You can use it as a matrix. You can do a sum matrix. For example, I have matrix 1, matrix 2. The sum of the matrix is, you can see, for example, the sum of matrix is every entry plus the other entry become this entry, right? 6 plus 2 is 8. Every entry is adding into that. So that's it. I don't want to teach you too much because matrix is boring. So you guys do it at your own assignment. Try to do other operations. For example, can you do a matrix transpose? Can you do a matrix multiplication? Can you do other things? If you are more advanced, try to do all those eigenvalue, whatever. But having said that, leak out the very unpleasant thing first. You do, of course, all these have already function in other packages like NumPy or whatever. They do have that packages already. But in order to do our CS1010, which is a 10,000 level course from basics, I have to train you to do that. You better know how to do all this, okay? By your own coding. Yes, over the boring part. Of course, you can do the two-day matrix not only for matrix, you can use it to store data in your table. For example, if I have some Excel sheet like that, I can actually convert my record into like that. Okay, and I can do any access. For example, what is the third student, which is Paul? What is his mark? So I can change Paul's mark into 100. I can use it as a database. Of course, usually it's very hard to remember because how do you know which column is what? So you can, one way you can solve it is use a dictionary. So the dictionary is your subject that map to a course index. For example, I want record 3, which the English, so-called the English marks. So I can use it to set Mary's English mark to 0. But this is still clumsy. When you reach the lecture of OOP, you will know that we have an easy way to do. But at this moment, you can actually do this as a database. And also, anytime if you employ the append function, you can add or even remove. You can remove any of this like a database. Okay, you can organize your classmates list or your home score, whatever, by append and erase. Yeah. Of course, you can do computations. For example, I want all the English marked. So I sum up all the English marked divided by how many students, then I can actually compute my average English marks. Right? But actually, I would say, because I'm from graphics, a lot of times, graphical spatial representation is a lot more interesting. What does that mean? That means each of the entry is not just a number. It is in a space, something occupying that space. Like a tic-tac-toe game. What is a tic-tac-toe game? I assume you guys know how to play tic-tac-toe. Anyone don't know? Okay. You know how to play tic-tac-toe, huh? Let's try to write a game like that. Actually, a tic-tac-toe game is super simple, right? Because it's a 3x3 grid. We call it a game, okay? This is a term I also first learned with this. What is a game? A game is a current game board configuration. Okay, the current game. We call it a current game is what is it until about how many circles or crosses are on the tic-tac-toe. It's called a game. How to represent a game? Super simple. If I used just now the function I did, I can use a create zero matrix, create a 3x3 matrix. They're all zero. And how do you make a move? Very simple lah. On that position, you ask the user to say, I want to input the position 1, 1 to be X or so on. But of course, that is for advanced user. Not normally people will do that, and it's too clumsy to learn. Because if you ask your 3-year-old kid to play that, what is 2, 1? Which position is that? He or she may not know. So let's try to make the game more easy to input for Franny. Actually, because the tic-tac-toe is so simple, you only have 9 positions, right? So why don't we just do this? I directly assign a number to each position. If I say input the number 5, you know which one, right? If I input the position 3, you know which one, right? Okay? But now the next problem is, how do I map each number into the column index or the row index? Okay? And you can do this. If the position is from 1 to 9, the column index and the row index is equal to this formula. Let's check. How about 7? 7 for the column, for the row index, right? I, row index I. 7 minus 1 is 6. 6 divided by 3 is 2. So it's row 2. Correct, right? Because row 0, 1, 2, the last row. How about 7's column index? Just 7 minus 1 equal to 6 modulo 3. And it is 0. It's the first column. And so on. So that applicable for all the 1 to 9. And the challenge is, how about the reverse way? Do you have a formula? I give you I and J. You tell me what number 1 to 9 it is. And this kind of thing in mathematical is called mapping. IJ map to a number of the position, and the position map to IJ. Okay, this is called bijective projection mapping. Okay, first, I want to create a game, right? I want to create a matrix like that. And if I want to do that, I want to put this X and O into my game to represent a game. So this is called printing of the game board. If I give you a 3x3 matrix, which is the game variable is a 3x3 matrix, I print the game board like that. First of all, let's explain this code one by one. What is this? This is printing the separator line, right? After I print a row, I print a separator. But if I have 3 rows, I only need to print 2. Otherwise, the third one has one more weird thing, which is not like the game separator. So if your column is, your row is 2, you don't print. And here, each line, I print this formatted string. This is a new thing in Python called formatted string. What formatted string will do is, in the string here, if first of all you give an F, okay, not swearing, not doing, you give an F. You give an F before the string. The string is called formatted string. What happened is, inside the formatted strings, if anything is being enclosed by this so-called bracelet, it will be evaluated instead of printing it out. Okay, let me demonstrate. For example, if I say print A plus B equals A plus B, okay? No problem, right? It's nothing. It's what you learned in the first two lectures. But if A is equal to 1, B is equal to 2, if I print again, what happened? Sorry, nothing. Still the same, okay? However, if I give an F to it, this become a formatted string. Is it okay? It will go into the placelet and evaluate whatever. Inside whatever can be even a function. You can say what are the functions? Absolute A minus B minus B. You can even put in any expression for it to evaluate. A is 1, B is 2, so this one is -3. But because I call the absolute function, it becomes +3. And of course, you can put all the function you roll, whatever. That is the interesting about Python. So here, you can see, I actually get a game row and the first column and so on to print out each of the row of the game. So this print TTT, print tic-tac-toe function will get you a 3D matrix. Sorry, not 3D matrix, 3x3 matrix, and print out the game board like that. And now let's create the whole game. So this game is called Play Tic-tac-toe, TTT gameplay. First, I create the game board, which is a 3x3 zero matrix. Here is a solution to the challenge just now. I put the number 1 to 9 into the 9 entries in my 3x3. It's okay? Sorry. And next, here, I actually have player 0 and player 1. You have two versions to play, right? You cannot play by yourself. So it's either player 0 and 1. So here, I represent player 0 is X, player 1 is the O. And you can see there's a loop. But in each loop, after one player finish, I do this, player equal to 1 minus player. What does it do? It toggle between the player. If this turn is by player 0, what is 1 minus 0? 1, no. Then become player 1 at the next time. If this turn is player 1, what is the next turn? 1 minus 1 becomes 0. So you can see back and forth toggle the player. Okay, this is line for that. And this one is I play 9 times. I will ask what is the player's input. The player will input the number 1 to 9, and I will convert it into the ij value and put into the player piece. The player piece can be X or O. Okay, so this is the O game. And lastly, of course, I print the tic-tac-toe game. So if I run it, I will do like this. First, I will print out this because every entry is empty. And the first player, X, will input 5. So X is in the 5 position. And then the player O input 3, and in the 3 position, and so on. I think I do have the code. Let's run. Okay, so yep. Yes, I do have a code. Okay, this is code. Is it? So player X, what do you want to place? Let's place 7. Okay, you see, X is placed here. player O move 5. Okay, and then player X do 8. And then player O do 9. And then player X will go to 1 to stop it. And player O will go to 4 to stop it. And player X will go to 6 to stop it. And now 1 is 2, 1 is 3, finish. Okay, so this is how the game goes. Okay. So this is the code. Any problem with this code? No problem? No, I don't mean you have a problem. What? Any bugs or whatever for this code? Any problem? What? Like what? You can just overwrite it. Is it cool? The player X occupy the central part. Player O reoccupied it. Okay? There's no error checking for the code. Is it okay? There's no error checking. So you can violate the rules. And that is your next assignment. I think there's one assignment to that. Can you write this to check how to validate a move? Okay, then when someone input something, can you tell is a move legal or not legal? Another problem? What is another problem? Any other problem? Yes, it won't tell you who wins. If somebody wins already, won already, then what? Continue play. Okay, there's no board, no game victory checking for this. And this another question for you. Okay, can you write a checking board winning? What does that mean? Can you write a code to input a 3x3 tic-tac-toe game board, check if somebody wins? Okay, it's sorry to tell you that one of the PE is checking not this. One of the PE is checking the checker game. Anyone know what is a checker game? The falling 5 in a row one. This one. One PE is that. 5 in a row game. This one. Give you a board like that, you need to tell me if somebody win. Okay? Think about that. How do you do that? One of the PE, I tell you first, this is what your PE is coming, okay? And if you can do tic-tac-toe, actually it's super simple, right? You can do chess. You can represent a chessboard like an 8x8 matrix. This is how you do it, right? So you can actually say the 0 is the empty space. And one character, let's say R represent the rook, K represent the knights, and so on. And you can use capital letter or lowercase to represent black and whites and play a chess game. But of course, this is not easy. This is not typical. How to make a move? Ritual times. That's how I play games when I study computer science. At our time, we don't have something called iPhone, whatever. Hello? Internet just came out at the time. So at our time, when we need to talk with somebody in other country, we need to pay Singapore dollar, $2 per minute to do the call for other people in other country. Okay, so when I study in US, it's not like you guys every time FaceTime home. No, they're not. I can call my dad or mom once in a month for 5 minutes. Okay, call, not face. And when internet come out, wow, we can type things over internet. So cool, okay? And we can even play chess game over internet, like typing in the chess to move what? Not mouse, we don't have mouse yet, okay? And that was how we play chess game in our time, okay? And how to make a move if you're doing this. But of course, nowadays, if you have an iPhone app, whatever, iPad app or Android app, it's just you have a graphical interface. the underlying game structure is still a 2D grid. Okay, it's the same thing. So how do you make a move? For example, how do you move a knight? Here, how do you make that? Okay, so one of the catch question is, you want to ask if a knight can move to anywhere in the board. That means, wow. Okay. Yeah, he owns. Okay. So if your knight can move to any position, that means if I can let your knight to move as many steps possible with obeying the knight's rules, can you move to any position? And what position can you move? And if anything stops you by not letting you go through some position, can you still move? That is some of the searching algorithm in Catus. Okay, so play around with it. What else can we do? Other board games. Okay, how do you represent this? It's actually a 2D grid. Think about it, how do you do it in a 2D manner? And I don't know whether you noticed that, and that's why not many of our games online have this, because it's a bit harder than the normal 2D grid. Okay. How about this? Anyone played this before? Anyone know what is this? Or where does it come from? No. What happened to our generation, Prof. Henry? You don't know what it is. You guys are not geeky enough, not nerdy enough, okay? You guys are too fancy now. This is from first, is anyone know that? Last minute. Yes? No, okay. This one is from first, the Big Bang Theory from Sheldon, but that's not the original source. But first of all, advertisement time, go watch Big Bang Theory, especially you are on the science or math whatsoever, okay? But this is Sheldon. He loved it so much because his idol, Star Trek, okay? Star Trek's still going on now. Some people wish it to stop, okay? Some people wish it to stop already. It's such a long franchise, like Star Wars. I'm not offending the Star Trek or Star Wars, but they're too long already. They should rest in peace. But they still keep producing, okay? Like what? Luke Skywalker still come up and die for you to see, okay? So I don't like that, okay? It's just stretching the thing serious, but it's in the beginning like that. So if you know how to do this 2D grid, you can program any games you want like this, or Sudoku, okay? Sudoku is also one of the PE. But of course, I won't ask you to solve a Sudoku. So at that PE, I ask you to verify if a Sudoku is valid solution. You know what I mean, right? Sudoku, you have this rule of every row has to be unique, every column is unique, and so on, okay? I will give you a grid to ask you to verify if a Sudoku is a valid solution. And anyone play this before? Minesweeper, right? Side story, computer history story. Do you know why Microsoft put this game into Microsoft Windows? Anyone knows? No. This is true, okay? I'm not pulling your legs. At the time, Microsoft produced Windows. There's one new thing they are pushing out at the same time. Is the, yes, who said that? Mouse. In the beginning, there was no mouse. People did not use mouse in the beginning. Mouse is like a new device. It's like our AI now. Wow, mouse. Okay. And what Windows did is they produced this. So they produced this Minesweeper game to train people to use mouse. It's a real story. Microsoft, that's why it's so weird. Why suddenly a window have this game Minesweeper in the window? It's so weird, right? Why suddenly? It's because Microsoft really want to train people to use the mouse to click each button very precisely, okay? And also train your eyes to get you blind. Okay, so that's how Microsoft did to train you to play this Minesweeper game. Other thing, this is my favorite. I know that not many people know what is this game. This a bit like Sudoku. What it does is give you the hints like that, not the picture. They won't give you the picture dot. Here, you have to use the logic. For example, this column here has one light color, one orange, one red, one black. So you have to place this on this column, and it's some uncertainty there. But if your logic is correct, you can use the logic to recreate the picture of the dog. They even have a 3D version. They make an object, okay? It's quite an addictive game. Once, be careful, once you play this, it's very addictive. Of course, end of this, you guys play, right? RPGs. Of course, I'm talking about the grid-based RPG lah, or any strategy game that you have to step and turn-based or war games. Then you can also play all this with the 2D puzzles, right? And Game of Life. It's called Game of Life. Again, sorry, today so many scary things. One of the PE did that, okay? What is it about? It's very simple. How do you determine the next frame? You know animation, right? One frame, one frame, one frame. How do you determine the next frame? Very simple. If your current pixel, for the first rule here, if your current pixel here have only one neighbor or two, have only one neighbor or no neighbors, you would disappear and die because of loneliness. If your current pixel here have more than 4 or 5 or whatever neighbors, you also die because of suffocation. You will survive if you only have 2 or 3 neighbors. And if any of this was empty before, but you did have 3 neighbors, is it 3 only? Yeah. Then you create 1 pixel from nothing to have 1 pixels, okay? And because of these 4 simple rules, you can make all this animation. Okay, for example, this one. And that makes it faster. Where's the speed? Where's the speed? Okay. They have a speed before. Where's the speed? They cannot control the speed. They used to have a speed. Okay. And you have other. Like this one. How come they don't have speed? It seems that it's random, but they're actually moving for something. It's a bit like life, okay? That's why this is called Game of Life. There's another board game called Game of Life, but this is another Game of Life. Where's the speed? They have a speed to speed up before that. Yeah, I think because of the server, whatever, they cancel that speed. And I have a lot. You play around yourself, okay? Yeah, like some of them are static, like this one. Yeah, so it's like a butterfly, it fly up, okay, because of animation. So this is called Game of Speed. Also Game of Life. So Game of Speed is another thing. Okay. Of course, you can solve the virus riddle at the beginning. So for those who miss it, you can go to talk to think about that. You can draw pictures. How about this? First, I create a 30 by 30 matrix. And now, what I did is I do these complicated things. What is these complicated things? I put a pound sign and a full stop in there, but under certain rules. And it will become like this. So if you want to go for this formula here, actually it just means if the index distance to the center distance for certain values, I'll put a pound sign. And that's why I will have this. Okay, so I can draw pictures. Remember the ASCII art? Okay, so all these ASCII art are just 2D ones. Okay, this one is all characters. But think about it. How do they produce it? Do they really humanly put one by one? No, you get an image, and then for each pixels or each area, you just put in the corresponding characters for the intensity. Okay, and of course, some people make crazy things like this. Some people actually really using the characters property. For example, 7 will make a line like that to create nicer, like that. Okay. Yeah. This one is Miko, right? Miko or Miko. Yeah. Okay. Are you ready to go one more dimension? For every number, instead I put a number, I put a list there. Okay. Instead of I put a numbers in each entry in the 2-dimensional array, I put a list there. So what we learned, a 2D array is a list of lists. It's like you have a vehicle. A list is a vehicle that contains other vehicle. And then inside the vehicle, you can contain people. 3D array is what? It's a list of lists. So it's a big vehicle containing smaller vehicle, and each vehicle can contain more vehicle. Okay? So it's a list of lists. So what is this? This is a list of lists. A 2-dimensional list, but each of them is a smaller list of 3 numbers. And there's our usual graphic format. If you use any graphic format like JPEG, GIF, I don't know if anyone still use GIF now, they are in this format. So what does that mean? This just means is RGB. Each of them is the number, how bright is the red R, how bright is the green, and how bright is the blue, RGB. And usually, most of our application use the number from 0 to 255. Why 255? 8 bits, the FF value, the largest number for 8 bits, 255, okay? Usually it's like that. And if you want to visualize this picture, it's like that. This is a zoom in one because it's 9 pixels, right? 3 by 3. Some of them are blue, some of them are red. So the picture is like that. But of course, what is fun? What is so fun if you create a picture of 3 by 3? Like if you play in your phone, it's like that, 3 by 3. So let's create a larger picture. This one, remember this? This is the picture of 30 by 30. But who cares about the size? Size doesn't matter. I can create 300 by 300. I use the same logic, but some of the pixel I put blue, some of the pixel I put red. And that's how I create pictures, okay? And that's why, if you remember, we have this before. What is this? One was the PER, I remember that. The P is asking you, how do you change this girls color from green to red. Or anyway, first, this is a package called image.io. You can install it on your Python. It's an external package, but it's super convenient. You can just do this. Picture is equal to image.io.read, and this picture is a 3D array. For example, what is so-called the length of a picture? Come on, tell me, what does it mean? What does this 900 means? What's that? Number of rows. And that is correct, but it's not usual our human language. If you talk about picture, what is this number about? It's correct, it's number of rows, but what you usually use human language to talk about? Width? Height or width? Height is the height of the picture, is it okay? Usually we say it's the height of the picture. So the height of this picture is 900 pixels. And then how do I know how many rows or what is the width of the picture? I get the first row of the picture and ask how many numbers are there. And then if I take 1 pixels, it tells you what is the color. I have RGB. We call it 3 channels. In computer graphics term, we call it 3 channels because some picture have 1 channel, which is the grayscale. Some picture has 4 channels, RGB and alpha. And what is alpha? You think you didn't know? You know. Alpha is transparency. You know that sometimes you go on the web, there's some picture with transparency, right? The background transparent. So alpha actually talk about what is the degree of transparency of that pixel. Okay? And we have some more. Some picture even have RGB CMY, cyan, magenta, and yellow, and so on. Some people have that. Yeah. So I can use this image.io and plotlib to just show it. Okay, so this is scarier, but you know this negative. I know that today no one knows what's a negative. In the beginning, we use some camera called have a frame. You know the frame roll, and this is how the camera record this. This is a negative, and it will develop into real photos. How do we do that? Very simple. We just here 255 minus that. For every colors, 255 is the brightest. 0 is the darkest. If I want to do negative, I reverse every numbers. If it's darker, I become lighter. Lighter become darker. Okay? But having said that, if you know how to use my deep map last time, I just need to map a function into the image without the for loop. You can do that. Okay? And yeah, this is one of the PE. How do I change a girl's color from green to red? Okay, so the answer is this. So for every pictures I get is RGB color. If the green color and is bigger than the red color and blue color, I do some math. I change its color value. Okay, then that's it. Okay, and of course, go up more dimension. Okay, but actually we already did. We already went up from 1 dimension to 2 dimension. 2 dimension now have a picture is 3 dimension. If you have a bunch of pictures, put it together, become a movie is 4 dimension, right? And so on. So it's not that hard, right? So go back to one thing we learned last time, how to read a CSV. Remember this graph? And remember to get babies? Last time we do this, right? But actually, we can just do this. We can just use the CSV package, import it, and this is called CSV reader. And you can see it just convert into a 2D array directly, okay? So I'm pulling your legs, okay? So last time pulling your legs, but of course, if you do assignment now, you know that not all text files are CSV format. That's why we need to know how to manipulate normal text file. But if you happen to just process a CSV, you can just use these few lines of code, read in a CSV text file, they will produce a 2D array for you with 1 line. You don't even need to use loop, okay? So it's more convenient this way. And yeah. So again, before we go, let me see another assignment first. Your next assignment. Hey, where's it? I'm not going to talk about this, but this one. Don't worry, it's optional. It was one of the PE. How do you make movies? Nowadays, people make movies, they do not create a real scene, right? You know that, right? You don't blow up the whole New York City for your Avenger movies. How do you make it? You are actually having these people in the studio, but their backgrounds are green. Okay, later I play you the video because I cannot record it now. And then afterwards, they superimpose it with the background. For example, instead of having an Avenger movies, I want the Avenger come into our SOC. Okay, so these Avengers are in the green screen. What I just need to do is think about it. How do I combine this picture and this picture into this one? I did it myself. How do I do this? If you understand the girl here one, it's the same thing. If in this picture, I recognize anything is green color, instead of drawing the left picture, I draw the right picture. That's it. Does it make sense? And if you can make one picture, you can make a movie. Okay? And do you know why now almost all the superhero does not wear green? Except who? Except who? Hulk. Why? Because Hulk is not an actor. Hulk is also the other layer put it on it. Hulk is an animation. So you can see the three layers: the background, the real actors, and Hulk. Does it make sense? Does it make sense? And that's why you see Captain America have no green, Thor have no green, Iron Man have no green, because all of them cannot have green. If they have green, they will be transparent, have the background. Okay? And that's why. So I put this one as optional. If you like it, do it yourself. You can even do your own image processing, okay? Do your things. You put it in the green screen and then you put your background. You are actually visiting Alaska. Okay, you can do that. Okay, so before we end, of course, if you understand this, can you do a 5th dimensional array or a 10th dimensional array? Actually, not that difficult, right? If you can move dimension 1 to 2, 2 to 3, 10 dimensional array is just a list of 10 times. Okay, it's the same thing. So answer the first question in the beginning of class, how many dimensions we live? According to string theory, we are living in the 11 dimension or 26 dimension, okay? Depends on which theory you're doing. It can actually solve a lot of problems. Your math problem, your image processing, if a lot of you actually continue engineering, you have this. One of my PhD thesis is actually related to engineering. We call it topological optimization. What does it do? My software try to optimize. For example, think about it. You want to create an airplane. What is the trade-off? You want the frame of the airplane strong, but you want it to be light. How do you reduce the weight? You use less material. I'm not trying to cheat, but there is a real problem. You want to try to use less material to create a strong structure. In engineering, we have this problem. They have some way they actually can do it. What does that mean? Engineering has some way to do something like that. Let me have some more complicated pictures. If you want to give a certain so-called, hey, they don't have enough holes. Yeah, this will show. So what is this? The rightmost one is actually engineering, especially material or mechanical, has a way to compute a shape with maximized strength for certain amount of material. But the problem is usually these algorithms will give you some structure with a lot of holes because they try to make the structure stronger, but try to support more. There's a lot of holes. So by reducing some of the holes, you keep a slight trade-off by the strength support you can do, but you optimize the topology. What is optimize the topology? You make smaller holes, okay? Make it smaller holes, why? Manufacturing, ma. You don't want to produce a shape that is so complicated for mass production, okay? So what does this do is this. So I actually do this before. So they do this, is called topology optimization. That means, okay, now, okay, the picture doesn't show. So this one. They don't let me see the picture. Okay, so this picture shows like that. They actually make some structure with a lot of holes, but then topological or optimization try to reduce it, which is in a 2D grid. For example, this is the structure they make a lot of holes, so they try to optimize it, which is a 2D problem. Okay, it's a 2D grid problem. You use some numerical method, you can do this. So it's one way to solve it. Okay, so I just want to say that a lot of time 2D grid or even 3D grid can actually help you to solve a lot of problems, especially spatial and geometric. Okay, so I hope you find this interesting and useful. Any problem? Okay. I will answer that later. Okay, and that's it for today. And I will show you the Avenger video for making. Thank you.